This video addresses the North Carolina Standard 7EE4. Use variables to represent quantities to solve real-world or mathematical problems. In this video, we will be focusing on Part B, construct inequalities to solve problems by reasoning about the quantities. Fluently solve multi-step inequalities with a variable on one side. Compare the process for solving equations to the process for solving inequalities. From the unpacking guide, this sentence applies to what we are talking about in this video. In addition, students use mathematical reasoning to explain the consequences of multiplying or dividing by negative numbers when solving inequalities. These problems I also pulled from the unpacking guide so you can see the types of problems students will be expected to solve. Why do you flip an inequality? The strategy we're going to use to answer this question is called a card sort, and we're going to be developing an understanding concerning when and why you change the direction of the inequality. Card sorts give students the opportunity to make comparisons, notice patterns, and think critically. I created a card sort that contains 36 cards. It pairs with this video so that if you like this activity, when you're finished watching the video, you can pull up this document, print it, and use it in your classroom. Like I would in my own classroom, I'm going to model how to fill in the cards like I would before I allowed students to work on this on their own. So what I'm going to do is I'm going to go through 6 different cards, and the first 2 examples are about adding and subtracting from both sides of the inequality. Let's begin looking at the first card, -3 is less than -1. What we're going to do for this card is we're going to add 3 to both sides of the inequality. -3 plus 3 gives us a sum of 0. And -1 plus 3 gives us a sum of 2. On the number line, I would then graph a 0, and then I would mark a 2, and I'd make a comparison. 0 on the number line is less than 2 because it is further below the 2. I would explain to students that as you move downwards on the number line, the numbers become smaller and smaller. And as you move upwards on the number line, the numbers become larger and larger. Then we need to answer the question about whether or not the symbol changed direction. We started out with a less than symbol, and we still have a less than symbol. So there was no change in the direction of the inequality. Let's take a look at example 2. 9 is less than 14. We're going to subtract 6 from both sides. 9 minus 6 gives us a difference of 3. 14 minus the 6 gives us a difference of 8. On the number line, I'll record a 3, and then I'll count 4, 5, 6, 7, and record an 8. We're comparing 3 to 8. Since 3 is further down in the number line than the 8, it is less than 8. We had a less than symbol at the start. We still have a less than symbol. So there was no change in the direction of the inequality. Let's go ahead and look at the next set of examples. In these 2 examples, we're going to be multiplying. 2 is less than 5. And we're going to multiply both sides by -3. 2 multiplied by -3 gives us a product of -6. 5 multiplied by -3 gives us a product of -15. On the number line, I'm going to mark 0 here at the end on the right, and then I'm going to count -1, -2, -3, -4, -5, -6. I'll mark -6, and then I'll continue counting. -7, -8, -9, -10, -11, -12, -13, -14, and -15. I hope you noticed that I purposely used both a vertical number line and then now I'm using the horizontal number line, because a lot of times I realize in my classroom that I'll just use the horizontal number line. And then I forget that I also need to be using with students the vertical number line. So I wanted to make sure I included that variety in this video. And now for the comparison. -6 is 6 to the left of 0, whereas -15 is 15 to the left of 0. And I would explain to students that the further you go to the left on the number line, the smaller the number becomes. And as you move to the right on the number line, the numbers grow and grow, they become larger and larger. So since -15 is further to the left, it's smaller, and -6 is larger because it is further to the right. So -6 is greater than -15. Did the symbol change direction? We started with a less than symbol and it became a greater than symbol. So there was a change in the direction of the inequality. Let's move on to the next example. Multiply both sides by 5. -1 multiplied by 5 gives you a -5. And 3 multiplied by 5 gives you a product of +15. The other thing I want to make sure I noted here was that I purposely put vocabulary words here, words that students are supposed to know. I think it's important in your math classrooms to constantly be using math vocabulary so that students are reminded of it if they've forgotten it, or if they don't know it, as you use it over and over again, they pick it up. Since I've already used the number line many times, I think you get the idea of what I would do in my classroom. So at this point, I'm going to speed it up a bit for the sake of time and just write down that -5 is less than 15. And you can see with the symbol that there was no change. And then we're going to move on to the next example, the next two examples. In these two examples, we are dividing. -45 is less than 0. -45 divided by 9 gives us -5, a quotient of -5. 0 divided by 9 gives us a quotient of 0. And -5 is less than 0. So if you look at the symbols, less than, there was no change in the direction of the inequality. Moving on to the next example, -10 is less than -5. We're going to divide both sides by -5. -10 divided by a -5 gives us a quotient of +2, and -5 divided by the -5 gives us a quotient of +1, and 2 is greater than 1, and you will see that the direction of the inequality changed. Now, if you'll take a look at this page, you can see that there are two labels. On the left it says direction of inequality changed, and on the right it says direction of the inequality not changed. You could approach this in different ways in your classroom. For example, let me just throw a few ideas out there. Maybe you want to have this displayed on a wall, and every group takes their cards that they filled in and places it in the appropriate categories on the wall. Maybe you want to have them create a set of cards at their own table and then have a gallery walk and see if each group put the same kinds of cards in the changed group and the same types of cards in the not changed group. Maybe you want to have two different displays. So maybe you have 30 kids and you want to have the changed and not changed categories on two different walls. And then you could have 15 students looking at one wall and 15 students looking at the other wall to notice the pattern. You want students, after they've sorted these cards into 2 categories, to examine the differences and try to start thinking about what caused the direction of the inequality to change and what caused the direction of the inequality to not change. So you have to decide how you want to do that in your own classroom. Then with students, I think it's really important to discuss the differences and what's going on and the pattern you see, and to write about the math. In my classroom, I would have a student share their reasoning, and then I would write exactly what they wrote on the board. For example, maybe a student said something like this: when you multiply both sides by a negative number, the direction of the inequality changes. So maybe the student came up with a summary for what they saw on this side, in this category. And they might not write something that's really beautiful the first time. They might not even have a complete sentence, but just write what they say on the board, and then together as a class, we'll read it again and think about if that's a good way to say it, and then we'll fix it together. It gives us a chance to write together and fix things together, and you're demonstrating to students the writing process in your math classroom. After you've summarized why the inequality changes direction, I think it's important to also summarize what does not change the direction of the inequality. Maybe you start with the students looking at addition and subtraction. Maybe a student shares something like this: adding or subtracting a number from each side does not change the direction of the inequality. Even if you were to add or subtract a negative number, it would not change the direction of the inequality. Finally, maybe students say something like this: if you multiply or divide both sides by a positive number, the direction of the inequality does not change. So this is important because students are noticing that in both categories, there's division and multiplication. But in the changed category, where the inequality flipped, we were multiplying and dividing by negative numbers. But in the category where the direction of the inequality did not change, we were dividing and multiplying by positive numbers. So we're really summarizing the pattern here, and hopefully students really understand what causes the inequality to flip directions. This video addressed the North Carolina Standard 7 EE4, use variables to represent quantities to solve real-world or mathematical problems. In 7th grade, the focus is going to be on solving inequalities with the variable on one side. I mentioned that because the next thing we're going to look at is the vertical progression. In 6th grade, students are expected to use substitution to determine whether a given number in a specified set makes an inequality true. They have to be able to write an inequality, so a simplistic inequality, and then they're supposed to recognize inequalities as having infinitely many solutions. And they're even supposed to represent solutions of inequalities on a number line diagram. In 6th grade, they're really first being introduced to inequalities, so it's pretty simple. And then in 7th grade, we already talked about the fact that students are going to need to be able to understand why the inequality flips and be able to solve inequalities that have a variable on one side. And then in 8th grade, the difference is that students are going to have to be able to solve inequalities that have a variable on both sides of that inequality. And then in Math 1, it says students were taught to solve two-step inequalities in 7th grade. In Math 1, students extend this skill to multi-step inequalities. So they were still working on multi-step inequalities in 8th grade, but in Math 1, they're really supposed to reach that level of mastery by the time they get through that Math 1 class.